Okay, so for each of these problems, all we have to do is change it into standard form and then graph the side of the equation that is not equal to 0, okay? So for this first one, we need to get it into standard form and we need to make one side of the equation equal to 0. The easiest way to do that is to subtract 3 from both sides. So now we're going to get x squared plus 2x minus 3 equals 0. Once we have this, now we have it in standard form. We're focusing on this left-hand portion, okay? Now, when we graph this, since it's set equal to 0, whatever our x-intercepts are, okay, those are also our zeros, which also become our solutions. Or another word for that is our roots to the problem, okay? So all 4 of those words are interchangeable because we've now set this equation equal to 0, okay? So let's go ahead and graph this guy. First, we need to graph him by using the fact that he's in standard form. We know that the axis of symmetry is x equals negative b over 2a, okay? This is all from chapter 8, okay? So our b value is 2, our a value is 1, there's a 1 in front of that x squared, and our c value is negative 3. So we're going to take negative and we're going to plug in 2, because our b value is 2, over 2 times our a value of 1. So we've got negative 2 over 2, which is just negative 1. So our axis of symmetry is x equals negative 1. And if you remember, for standard form, after we find the axis of symmetry, our next thing to do is find the vertex. And we find the vertex by plugging in the axis of symmetry into our original equation. So now our vertex, we're going to take x squared plus 2x minus 3. I got that equation from the original once I put it into standard form. And then I'm plugging in negative 1 wherever I see an x. So we've got negative 1, we're going to square it. We're going to add 2 times negative 1, and then we're going to subtract 3. Negative 1 squared is positive 1. Negative 2, or positive 2 times negative 1 is going to be negative 2 minus 3. We're going to get 1 minus 5, which is negative 4. Once we have the negative 4, our vertex now we know is negative 1, the axis of symmetry, comma, the value that we got when we plugged it in, so the negative 4. All right, and then last but not least, we also need to use our y-intercept. Our y-intercept here is just the same as our c value, which is negative 3. So there's going to be a point at 0, negative 3. The y-intercept is at negative 3, okay? So once we apply all of this to our graph, we're going to get an idea of what our graph is going to look like. So an axis of symmetry down x equals negative 1. All right, and then once we put that, our vertex is at negative 1, negative 4. And then once we have that, we know that our y-intercept, where it crosses the y-axis, is at negative 3. So there's a point right here. Remember, the axis of symmetry is symmetrical. So both sides of the axis of symmetry are identical. So this point is also going to occur over here because it's symmetrical on both sides. A parabola has complete symmetry about its axis of symmetry, okay? And then to the best of our abilities, we're going to draw the graph of the parabola. And you should notice, for all of our examples, they're going to intersect the x-axis at a whole number, okay? And I notice my graph intersects negative 3 and positive 1. So my x-intercepts are negative 3 and positive 1. Those are my answers, okay? Now, since we are graphing it freehand, right, we always want to check these answers by plugging them back in. So this is a required step. We need to write check, and we're going to check our answers. So we're going to write the original expression. You can either write the original equation from the very beginning or the standard form. I'm going to go ahead and write standard form. So it's x squared plus 2x minus 3 equals 0. X squared plus 2x minus 3 equals 0. And then we're going to check by plugging in. So we're going to say, all right, x equals negative 3. That's one of our solutions. And then we're also going to have to check x equals 1. So we're going to take negative 3. We're going to plug it in. It'll give me negative 3 squared plus 2 times negative 3, and then minus 3 should be equal to 0. Let's see if it is. Negative 3 squared is going to give me 9. 2 times negative 3 is going to give me minus 6, and then minus 3 will give me 0. So 9 minus 6 gives me 3. We subtract 3 from 3, we should get 0. 0 equals 0. So this one works. X equals negative 3 is definitely a solution, okay? Now, if you picked a point, let's say you drew your parabola a little bit off, right? Like, let's say you made this a little bit too wide and you went to negative 4, right? You would then realize once you plug in negative 4, you're going to get like something that's not equivalent to 0 on the left-hand side. And you know that it's not going to work. So you would put an X and you would recheck it. So you could redraw your parabola and realize, oh, maybe I just drew it too far. Or you could figure out what went wrong, right? But for us, we checked negative 3. We know that it's a solution. So now we just have to check 1, okay? So we're going to plug in 1 to our original. We're going to get 1 squared plus 2 times 1 minus 3 equals 0. 1 squared is 1 times 1, which is just 1, plus 2 times 1, which is 2, minus 3 equals 0. 1 plus 2 is going to give me 3. Subtract 3 from that, and you should get 0 equals 0. This one works as well. So I know x equals negative 3 and x equals 1 are our solutions, okay? Now, this example had 2 solutions. We are going to see examples that have 1 solution, and we're going to see another example that has no solution, okay? So let's go ahead and start by checking out the example that has 1 solution. All right, so go down to this example where it says 1 real solution. We're going to deal with x squared minus 8x equals negative 16. Again, you always have to change these guys into standard form. This one is not because neither side is equal to 0. In order to set this equal to 0, you need to add 16 to both sides. Once we add 16, we're going to get x squared minus 8x plus 16 equals 0. This is what we call standard form. And from here, we can take the left-hand side and we can graph him, okay? Once we graph him, our zeros will be our answers because this is set equal to 0. So the first things first, we need to find the axis of symmetry. Our axis of symmetry is x equals negative b over 2a, which is going to be negative 8 over 2 times 1. This is going to be positive 8 over 2, which is positive 4. So x equals 4 is my axis of symmetry. I take that value, I plug it in to find the vertex. So remember, my vertex, we're going to use x squared minus 8x plus 16. And we're going to take the 4 and plug it in wherever I see x. So this will be 4 squared minus 8 times 4 plus 16. This is going to be 4 squared, which is 16, minus 32, plus 16. This will give me negative 16 when you combine 16 and negative 32, plus 16, which gives me 0. So my vertex, my x value is 4, and my y value is 0. And then last but not least, you have to figure out what the y-intercept is. It's just going to be your c value, which is 16. So we're going to say y-intercept is 16 or 0, 16. All right, so we go to our graph. We know that our axis of symmetry is x equals 4. So a dotted line down the axis of symmetry of 4. And then we know our vertex is at 4, 0. And our y-intercept is somewhere up here at 16. We'll do a makeshift 16 since our graph doesn't go that high. And we'll draw a nice parabola that connects to that point. Okay? All right, now you'll notice what we care about is we care about at what point does our graph cross the x-axis. And this one turns out to only cross the x-axis at exactly 1 point. And that point is when x equals 4. So x equals 4 is our x-intercept. And that's our solution, okay? Now, even though it seems redundant to check, you must always check your solution, okay? So we have to check this. So we're gonna take 4. For a change of pace, I'm gonna plug it into the original. You're gonna see it works regardless of how you do it, but I'm gonna plug it into the original. So we're gonna take x squared minus 8x equals negative 16. Now you could plug it into the standard form or the original. Either way, it's up to you. X squared minus 8x equals negative 16. The value that we're checking is x equals 4. We plug that in, we're gonna get 4 squared minus 8 times 4 equals negative 16. 4 squared is 16 minus 32 equals negative 16. Negative 16 equals negative 16. So I know this indeed is a solution. So this one, as you notice, has exactly one solution. Okay? This happens when the vertex lies on the x-axis. Okay, so this one was good. We got one solution. And the last example that we're gonna do, we're gonna see an example where we get absolutely no solution, okay? So let's check it out. So we're gonna do this example where it says no solutions, and we're gonna do example 3, letter A, all right? So same thing, we have to make sure that one side of the equation is equal to 0. So for this one, you could totally subtract 2x from both sides. You could subtract 4. I personally would just add x squared to both sides. It makes things a little bit easier. So we get 0 over here on the left equals x squared plus 2x plus 4. Now, if we're being picky, standard form does have the 0 on the right-hand side, so you should rewrite it as x squared plus 2x plus 4 equals 0, okay? Now, once we have this, we need to graph the left-hand side to figure out, okay, our graph is gonna tell us the x-intercepts. Those x-intercepts become our solutions, okay? So our graph is axis of symmetry, and then find the vertex, and then find the y-intercept. So our axis of symmetry is gonna be x equals negative 2 over 2 times 1. This is gonna be negative 2 over 2, which is negative 1. So our axis of symmetry is x equals negative 1. We take that negative 1, we plug it into our original. We're going to get our vertex is going to be x squared plus 2x plus 4, where we're plugging in negative 1. Negative 1 squared plus 2 times negative 1 plus 4. We're going to get positive 1 minus 2 plus 4. This will be negative 1 plus 4, which will give me 3. So my vertex is negative 1 comma 3. And then last but not least, let's go ahead and get that y-intercept. My y-intercept is just my c value, which is 4. So my y-intercept is 4. It's going to intersect at 0 comma 4 with the y-axis. All right, so x equals negative 1 is this vertical line. That goes all the way down. Negative 1 comma 3 is my vertex, and then 0 comma 4 is my y-intercept. There's also a point over here because the axis of symmetry is symmetrical, and we draw our parabola. And we're gonna notice our x-axis is never intersected by the blue parabola, okay? Now, it looks like it is because the axis of symmetry goes through the point, okay? But remember, our axis of symmetry is not actually part of our graph. The only part of the graph that you care about is the parabola portion, okay, right here. And this parabola will never intersect the x-axis. Therefore, we have no solution. And we have no solution because there are no x-intercepts, okay? That's it.